With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. A chain of mass per unit length lambda and length 1.5 meter rest on a fixed smooth sphere of radius r is equals to 2 by pi meter, such that a end of the chain is at the top of the sphere while the other end is hanging freely. The chain is held stationary by horizontal thread PA, and the tension in the thread you have to find out. So if you cut this, let's say this is the chain and we are dealing with this part. So if you cut this string from here, cut this chain from here, right? What you will see, the tension here, let's say it is T1 and we want the tension here. So let's move from here to here. Like if you see, let's say as I told you, let's say here the tension is T1 and we are moving toward T2, right? So we can get this T1 simply by writing the force equation on this part which is below this, right? So if you see here below this, you can calculate this length. If you see, the total length is this, right? And this radius of this part which is on the sphere is this. So I will write the length of this part which is on the sphere, it is pi r by 2. 2 pi r by 4, that is pi r by 2. Put the value of r, it will be 1. R is 2 by pi and it will be 1. So 1 meter is this length. So remaining length this, it is 0.5 meter. So the mass will be this, right? Now I can write down this T1 is equals to lambda g by 2. Now if you see here, if I move from T1 to T2, right, the tension will be varying in between. So what we will do is we will take a small element at an angle of theta, and this element is d theta, and you can get this mass of this part. So I will write the mass of this part is mass per unit length into length. So length, you can see it will be simply arc length, that is r d theta. Mass per unit length is lambda, right? So I will write here the mass of this part, it is dm, and dmg will act in downward direction, and this mass will be lambda times of r d theta. R d theta is the length and lambda is the mass per unit length, right? Okay, so this is stationary, right? So net force on this should be equal to 0. Okay, so if you see along the plane, this is along the plane, this line is along the plane, this line. Along the plane, net force would be equal to 0. So I will write the T plus dmg cos theta is equals to T plus dt. Here the tension will be more, that's why dmg cos theta is being balanced here. Now this t will get cancelled out and I will write this dt is equals to dmg cos theta. Now you can integrate this and the theta will be varying from 0 to 90 degree. So just integrate it and you can also put the value of dm we already got, it is lambda r d theta. So if I put the value of dm lambda r g this. So here if I write down, the angle is varying from this. So it will be t minus 0 is equals to this, and integration of this cos theta is equals to sin theta. 0 to 90 degree. Now put the value. So sine 90 is 1, sine 0 is 0. So from here you will get this as the tension difference. So as I put the value of 0 to t, so I got this tension difference. So we know already at theta is equals to 0, we already have taken this, it is T1. At this point the tension is T1 and here the tension is T2. So this T is delta T actually, right? So let me put here T1 to T2. So if I put the value of T1 and T2, I will write this. So from here I will write this T2, the tension in the thread is equals to plus T1. T1 we already have seen, it is this lambda G by 2. So this will be the tension and answer of this question. Now you can check for the option. Put the value of R also. R you can see it was this. So if you put the value of R and take lambda G common, you will get in the bracket 2 by pi plus half. So 2 by pi plus half. So this A will be the correct option. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.